Hello class and professor. This is my microcosm project. I undertook this assignment in the hope I could create a working ecosystem with the little resources I had available due to it being winter. My hypothesis for this project was that having at least one autotroph and one heterotroph will allow the microsome to flourish. I went about building my microcosm by using materials under a bridge in Hampton, Virginia, located where this arrow is pointing. I then placed everything in a 24-ounce jar. The materials in the jar include 12 ounces of seawater, 198 grams of mud, while 1/4 of the jar remained empty for air. I also included a stick and a rock for non-living materials. For living organisms in my microcosm, I included roots to some sort of shore plant, algae, a barnacle, and a snail. This project ran for a total of 8 weeks. In those 8 weeks, my microcosm remained in a temperature-controlled environment that ranged from 69 to 71 degrees. It also was exposed to indirect sunlight for 9 hours of the day until the sun hid behind my neighbor's house. Over the 8 weeks, I did not observe much change in my microcosm. That was mainly due to the vegetation not growing as quickly as I thought it would and my snail's death. Here is a picture of the first day I collected my microcosm. The water hasn't quite settled yet. These next images are of the following weeks. Week 2 is the week the snail died. Once that occurred, there's not really no observational change to the water or anything. But because the snail died so fast, there was not enough time for growth in the plants to see if if the snail's death affected the plants. Here is the final picture of my microcosm. Oddly enough, it looks like the roots have some sort of growth on them. This could mean that even without the CO2 the snail would have produced, the plant did not need as much because growth is so slow. The take-home message from this was mine did not do very well. This is probably due to there not being enough heterotrophs. Therefore, what I learned that the death of one creature put my entire microsome at a stalemate and prevented any further growth. Therefore, my hypothesis for for my microcosm was not supported. Microcosms are an important tool because they can simulate the natural behavior of an ecosystem. They can simulate biogeochemical cycles by including or excluding elements. They can simulate ecological communities by including or excluding species of animals or plants, and they can also simulate diversity by including or excluding a number of one species or another. Not only can scientists look at all these things, but they can also without altering the actual ecosystem, they also have more control over the experiment. For further research, I would like to test and see if see if I were to put already grown plants in the same microcosm, if they were to stay the same, die, or grow more. To improve the chances of me seeing this happen in the same or similar microcosm, I would definitely incorporate more heterotrophs so the death of one wouldn't stunt my experiment completely. And that concludes my presentation. Thank you for listening.